Before we can start generating reports and validating our static pressure and airflow velocities, the ductwork systems have to be checked to make sure it's assembled correctly. Revit cannot calculate static pressure loss or properly calculate airflow velocities if the ductwork system is incomplete. So we'll examine the main items within the Revit model. So there's 3 items to look at within a Revit model to make sure that the system is complete. And these items are checking the system of ductwork disconnects, check the systems for any warnings, and verify that the duct connector properties are set properly. And in the duct connector properties that need to be verified, there are 3 parameters that we're going to be looking at closely. The first parameter is the flow configuration parameter, which can be set to the value of calculated, preset, or system. The next parameter is the flow direction parameter, which can be set to the value of in or out, and on occasion bidirectional. And the third parameter is the system classification parameter, and the value of this parameter can be set to supply air, return air, exhaust air, other air, fitting, or global. Now we'll go into greater detail about these parameters and what each value means while we're in the Revit model. So with this information, let's open our model and start verifying our system. To start, we need to see where our duct systems stand. So we're going to go to the Analyze tab, and on the Check Systems panel, select the Show Disconnect button. Now this brings up the Show Disconnect Options dialog box. And as you can see, this dialog box allows you to check for disconnects on many different systems within a Revit model. Since we're checking only the ductwork systems, you only need to check the box next to Duct and select the OK button. And this will place a warning signal next to all duct connectors within the model that are not connected. And if you select one of these warning symbols, Revit will provide the associated warning to the symbol. And once the warning's been read, just close the warning dialog box to move forward. A couple things to keep in mind using the Show Disconnects command. Once you've checked the box within the Show Disconnects options dialog box, Revit will identify the disconnects for that system until you open the dialog box again and uncheck that box next to the system. So that your screen is not as cluttered, it's a good practice not to leave your disconnects checked. So to turn your warnings off, just select the Show Disconnects button on the Check Systems panel, and within the Show Disconnects Options dialog box, uncheck the box next to Duct, and after you select the OK button, the warning symbols will be turned off. The other thing to keep in mind, in the Show Disconnect Options dialog box, you can select as many of those boxes at once as you'd like. Now the next item to examine is the duct systems themselves. To do this, go back to the Analyze tab, and on the Check Systems panel, select the Check Duct Systems button. And what this button will do is show you the warnings related to the duct systems. And as before, Revit will display a warning symbol for each duct system, along with green dashed lines showing what's connected to that duct system. And similar to the disconnect duct warnings, the Check Duct System warning symbols will remain on until you select the Check Duct Systems button on the Check Systems panel again. And this effectively turns them back off. Let's go ahead and leave these warnings on for now. And we're going to start with this warning right here and see what it has to say. And when you select a warning symbol, Revit brings up the warning dialog box and highlights the entire duct system. This warning is a common warning. Revit's found a mismatch with the flow in this duct system. And what this common warning means is that the flow direction parameter is set incorrectly on a Revit family in this system. An important item to note, Revit refers to equipment in this warning. Revit uses the term equipment generically to identify anything within the duct system that is not a duct fitting or duct work. So in this case, Revit is using the term equipment to describe the terminal box that is part of the mechanical equipment category and the supply air terminal, which is actually in the air terminal category. So close the warning dialog box, and we'll start to fix the warnings by checking the duct connector parameter values in the terminal box family. To do this, we'll need to edit the family. So select the terminal box, and on the active Revit, select the Edit Family button, and this will open the terminal box family. Now, while in the terminal box family, rotate the 3D view to get a better angle on the outlet of the box. We want to do this because this is the connector that is part of the duct system we're examining. And once you select the duct connector, you'll notice that the 3 parameters mentioned earlier are now in the Properties palette. And that's Flow Configuration, Flow Direction, and System Classification. Now we're going to start with the flow configuration parameter. This parameter has 3 options to choose from: calculated, preset, and system. If the flow configuration parameter is set to system, it will use the algorithms associated with the system classification to determine your pressure drop. If the flow configuration parameter is set to preset, what it will use is the value that you put into the family and ignore any value that Revit calculates. And calculated uses the project algorithm to determine the overall system pressure drop. One thing to keep in mind with the flow configuration parameter is within a duct system, Revit requires at least one of the duct connectors to be set to calculated. So to help keep confusion down in a firm, it is a good practice to standardize on what the value of your flow configuration parameter is for all your Revit families. Next, you have the flow direction parameter. And within this parameter, you will always have the in or the out value. And in this case, we have a bidirectional value, but that value is not always available. The bidirectional value shows up when you are editing a family that has multiple connectors in them of the same type of connector. In this case, there's 2 duct connectors within the terminal box family, so it gives us the option on the flow direction parameter of bidirectional. The in and out values are exactly what they are. The airflow is either going in or out. Now, this is in relationship to the connector, not to the family. And since we're dealing with the outlet of the terminal box at this point in time, the flow direction is set properly to out. And finally, we have the system classification parameter. And within this parameter, you have the options of supply air, return air, exhaust air, other air, fitting, or global. The supply air, return air, and exhaust air are hard-coded to allow you to only connect to those specific systems, while the other air option allows you to connect any of your custom duct systems to this connector. And then the fitting and global values for the system classification parameter are actually system agnostic, but the fitting value will remain system agnostic even after you've connected a system to it. While the global option of the system classification parameter starts out system agnostic, it will take on the system characteristics once a system is connected to it. And the system classification parameter is currently set to supply, which is correct. And since all the parameters for the terminal box family are correct, we're going to close this family without saving it or reloading it into our Revit model. Now the next family to check is the supply air terminal family. And just like the terminal box family, go ahead and select the supply air terminal, and on the active ribbon, select the Edit Family button. And with the supply air terminal family open, let's review the values of the flow configuration, flow direction, and system classification. And the flow configuration parameter is set to the value of preset, which is correct. And the system classification parameter is set to the value of supply air, which is correct. And the flow direction parameter is set to out. And initially that seems correct because on a supply air terminal, the air flows out of a supply air terminal. But remember, the flow direction parameter is in relationship to how the air flows across the connector, not necessarily the part. So, since this connector is the inlet of the supply air terminal, the flow direction parameter actually needs to be set to in because the air is flowing in to the family at this point. So let's change the flow direction parameter to in. And since we made changes to this family, we're going to select the Load into Project and Close button on the Family Editor panel on the Modify tab on the ribbon. Now you'll be prompted to save your family. For now, just select No. And since the supply air terminal family is already loaded in the model, Revit will bring up the Family Already Exists dialog box. And in this dialog box, you'll want to select the second option since we changed the parameter value in the family. And with the supply air terminal family reloaded and updated in your Revit model, you'll notice that the warning signal for the duct system went away, and this is because we fixed the warning. Now moving up to the next system, when we select this warning signal, another common but different warning appears. And basically all Revit's saying in this warning is that you have disconnects within your ductwork system. So we need to verify all your duct connectors are connected. So close your warning dialog box and check your duct disconnects by going back to the Show Disconnects Options dialog box and selecting the box next to the duct. When you select OK, you can see that the rigid ductwork and the supplier terminal at the end of the run is not connected. So let's connect these two items with a piece of flex ductwork. And once you add that flex ductwork, you'll notice that the warning signals for the duct system and the warning signals for the duct connectors both went away. For now, these are the only two systems we're going to be fixing. So go ahead and turn off the warning signals by going back to the Show Disconnect Options dialog box. and select the Check Duct System button again to turn off the warning signals for the duct systems. And now with these edits made within your Revit model, these duct systems are ready for us to generate our static pressure loss report on them.